Okay, so we're gonna do warm-ups 9 and 11. Number nine, what's wrong? Um, so this is a square root graph, and we're gonna do this without a calculator. We're gonna be smart. Um, and we're gonna figure out nice numbers that will work for us. It's gonna take a little bit of brain. I know, I know. Okay, but can you guys tell me what the end point is? So remember, square root functions have an end point. What's the end point for this one? -5, 0. Okay, so you want to make sure to start your table with that for a square root function because everything before that's going to be a negative under the square root. So this is not the style where you put it in the middle of the table because anything that you plugged in below that would be a negative under the square root, wouldn't work. You guys remember how like the table and the calculator would give you error, 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 error. Okay, this is the first one that would work. Okay, now -5. Square root of 0 is 0, right? Okay, what's the next nice square root? So square root of 0 is 0. What's the next nice one? 1. What number can I plug in here to make this 1? -4. Okay, and then if I make that negative here, let's just do. Okay, so pretend this is parentheses. So -4 plus 5 is 1. Square root of 1 is 1 times 2 is 2. You guys okay so far? Okay, what's the next nice square root? 4. Okay, what could I put under here to make this 4? -1. Okay, let's see if we can get the shape from this. -5, 0. -4, 2. -1, 4. Yeah, that's pretty good. It looks good. Okay. Oh no, I didn't go through the point though. Okay, so we have an A value of 2. Vertically stretched by a factor of 2. H is -5. Yep, shift left 5. And then we don't have to put any, we can put K is 0, but we don't need to put a transformation in there because we did not shift it up or down at all. Okay, now scooch down to number 11. There's a lot of space. I really don't know why, but okay. Inequalities. Step 1, pretend it's equals. Step 1, pretend it's equals. Step 2, solve. Open or closed? Open. Yep. Feel like this is gonna be false because whatever's gonna be over here is definitely not gonna be less than negative 108, but whatever. Okay, so this is -8. So this is times 1. 1 minus 0. Here, I'll write it. Also, all that work for knowing that something's not going to be less than negative 108. That's okay. Okay, so that means I have a big false flag on 0. Yep, so that drives my arrow the other direction, the true. But you have to find the final answer. V is less. Oh, wow. Wow. I really made a giant less than symbol. Negative. Okay, next question I have for you is how do you feel about drawing, say, a lot of axes? How do you feel about axis drawing? Axes, pictures of axes. How do you feel about using a straight edge to make axes pictures? I feel like maybe you should mentally prepare for making some axes. That's not finding me funny. No one finds me funny. 7 axes. 7. 6 or 7 axes. Actually 7. There's 6 in the first problem, plus 1 in the second problem, and make it 7 axes. But 6 axes first, and then 1, and makes it 7 axes. So 6 or 7 axes, depending on if you're in the first problem or the second problem. How do you feel about axes? Yes, but what you're not excited about axes drawing? I already drew the guy before you came, so. I'm afraid I'm recording, but I said I'm recording. Yeah, axes. You could draw him an extra birthday axes if you want. I gotta do safety. All right, well, you guys got axes. I'm gonna pass some papers back to see how much time I have to pass back papers, but do not focus on me, focus on axis drawing. How many axes are there?
6 or 7.
6 or 7. There really are 6 or 7.
Good job, Lee. Good job.
What are you on axis drawing?
No. We're doing a bunch of natural class. And I have to. I didn't keep running this guy or something. I was, I didn't know that. Yeah, but.
I don't know if you're gonna just do the axes across there.
Yeah.
Okay.
No, my. So. Not.
It's like, thank you. I have a text. You're super sure about. That's life though. Comment about the stack of papers that I have, what do you do about it? This. Yeah.
Guess what I got? Well, I got 40 on. I got.
Yeah, but they're not. Eighteen. That's probably good, Danny. Yeah. I like split action. Yeah, we've done it 17.
Wait, what did you get in the world?
I got one from
Hold on, maybe.
What did you get?
We didn't get all the time. No, I have you realize.
Oh, I guess I did.
Okay, hi, moving on. I am going to use two colors on this. Just so you know, I'm gonna use my pink.
Three more.
How long does it take you to do it?
Starting from.
Okay, so what we're going to do in this problem is we're going to say what the inverse is of each paragraph. Some of them we haven't done yet. Some of them we have. And then we're going to do our best to sketch it on a couple of them that are kind of weird. So just so you know, why we don't have a lot of problems that have certain ones. We stick to certain kinds because some of them are strange. But okay. First, A, this is y equals x squared. This is a parabola. What would the inverse of a parabola be? And there's actually two answers. Sleeping parabola. Okay, now we can write it two ways. We can write y inverse equals plus or minus the square root of x. This is what you would find if you did like our math 3 style with the steps, forward steps and backward steps. Does that make sense, you guys? Okay, or you could write it x equals y squared. That's the parent graph for a sleeping parabola, but those will be the same thing. This one's kind of nice for graphing calculator purposes. So what we're gonna do is sketch it as best we can. So here's my original. Just a regular old everyday parabola. And then I'm going to literally turn my notebook 90 degrees and try to draw the same thing. And we're going to use that pattern as we go to help us with the weird ones. Okay. Does it make sense what we're doing in this problem? Okay. B. What would be the inverse of a cubed? Cube root. No plus or minus necessary. And when you draw your cubic and cube root, don't forget to put the flat bit. So it's going to come up from the bottom, flat bit, continue up. Yours are good? Excellent, because this one's going to be bad. Okay, now literally rotate your notebook. Yep. Okay, now here's the thing. It's got to be reflection on y equals x, right? So it's got to start this way. I didn't even draw anything yet. Oh, size of my loops are not even. Those are supposed to be the same. I'm not supposed to have a big one and a little one. I'm supposed to have the same size. Okay. Now, y equals x is a line. What's the inverse of a line? A line. Okay. So x equals y. Yeah. Okay. Barrett's got it. This one is weird. The inverse is itself. Because if you flip this around, it's the same thing. Ah, okay. Also, think about it graphically speaking. If you draw the line y equals x, it's on the line of reflection of y equals x. It is the mirror. Okay, now I'm gonna ruin my pen. I know. Okay, now here's one that we don't really do that much, because we have to do like a piecewise situation for the inverse. But when we do absolute value equations, how do I tell you to undo them? Plus or minus of the constant side, right? Okay, so the inverse is plus or minus x. Okay, however, it's only a piece of it. So think about it this way. You know this is a v, right? Use the graph to help you. Your inverse is going to be a sleeping v. Okay, and this is why we don't really do inverse problems for absolute value, because it comes out to be a sleeping v. Okay, now the lines plus or minus x are actually lines that go on forever, and this stops. So this needs what's called a domain restriction. You have to say only the positive bits. Okay. Same thing's gonna happen here. This is also gonna be a weird one. So square root of x, luckily we did one of these in the warm-ups, so we could sort of remember what it looks like. It looks like that. Okay, so remember it has to be a reflection across the line of y equals x, so it's gotta go this way. Remember the reflection. Okay. So what is that? What is this thing?
Just one.
It's half a parabola. Yeah. Okay. So the inverse is a parabola. However, you only want the positive bit again. You see why we don't have a lot of problems with square root of x and find the inverse. You see why we don't have a lot of problems with absolute value of x, find the inverse. You see why we stick to these guys here in your problems. Okay, now I know, we did one of these, number 24. And here's what it looks like regularly. Here's what it is regularly. What is the inverse of a rational function? It's the same thing itself again. Shh. Oh no. I was listening to someone who made a mistake and then I made a mistake. Okay, would anybody like me to show them why this is what it is? Yes, okay. So, do you want me to show you in steps or by flipping X and Y?
But
Okay. Okay, first I'm gonna do the method that we did in number 24 where I change it to the x to the negative 1 power. Okay. What's the only step that happened to it? Negative 1 power. Yeah. Okay. What's the inverse of the negative 1 power? A negative 1 power itself. So x equals y to the negative 1. Just got back to itself. Okay, again, remember, what did I say when we did number 24? I said that was a pre-calc problem and not to worry about it. Did I not? Okay. All right, now, so where are most of our inverse problems going to live? The top three. The top three. And I probably will never give you one of these. I don't know about pre-calc. I don't know about pre-calc here. I know they do these in pre-calc for sure. Okay, but for us, we're going to do these. Okay, however, we're now going to explore what happens with an exponential. That's one of the blue sheets we have not messed with yet. 3 to the x. Okay, and you guys get when you're ready, get your two colors and your straight edge for the graph. Yes, honey. Yeah.
Can we not? Can we not? Can we not?
Okay, so you guys, we need to slow down now and focus, because this is going to be the second half of our chapter is inverse of the exponential. The first half was just like inverses of all the easy stuff. Now we're going to do inverse of an exponential, but we're going to do it very slowly and carefully. And the first thing I'm going to do is make a table for the original. Okay, now I want to get my blue sheets and talk about what is the locator point of an exponential. Please stop whatever that is, please. What? That's a rational function. Okay, so there is an asymptote. So that makes the locator point h comma k plus a. Okay, so come back over to this. Just put up here h comma k plus a. And h is anything after the x in the exponent. K is anything outside, and a is anything in front of the parentheses. Okay, so this is a very simple one. Is there anything after x in the exponent? No. So h is 0. Is there anything adding or subtracting onto the end of this? No. So k is 0. Is there anything in front of the parentheses of the 3? No. So a is 1. This is the very basic one. You guys understand what I'm saying? Okay, so the locator point is 0, 1. Put 0, 1. Yeah. That's to the y value. Okay. All right, so now we're gonna go our usual. Okay, do the easy ones first. What's 3 to the 1? 3. What's 3 to the 2? 9. Okay, now, important question. What's 3 to the negative 1? 1/3. Remember, it goes downstairs. What's 3 to the negative 2? 1/9. Great job. Okay, we're not going to graph 2, 9, but it's going to help us. So 0, 1, 1, 3, negative 1, 1/3, 2, 1/9. You can see the asymptote starting to form there. Ooh, wrong thing. Okay, now flip the table and graph whatever the inverse is. We don't know what the inverse is yet. We haven't studied it yet. This is our first baby problem on this. But we do know that we can get the inverse by flipping the table. Okay. Then just humor me and rotate your paper 45 degrees counterclockwise. So tell me, does that make sense to you as far as what you know so far about inverses? Can you see the reflection on the line y equals x? Okay, so the thing is, we know what it looks like. That's what the inverse looks like. We just don't know what it is. Like, what is that graph? What is that thing? Honestly, you've never done it before. But we're going to temporarily call him something. That's what we're going to call him. How did I get that temporary inverse? Okay, let me ask you this. What do you do to make a table, an inverse table? Yes. Yeah, flip the variables around. So I just flipped the variables around in the equation. I'm not gonna leave it like that, because you can't put that in a graphing calculator and it's not gonna be helpful. That's not the final answer. It's just a holding spot for us for right now. Okay. Now, I want you to set this up. Yep. Okay. I'm gonna show you a problem. Okay, are you guys ready? Did you set it up? Okay. All right. Parts A through F below are similar to a puzzle that is more than 2,100 years old. Mathematicians first created the puzzle in ancient India in the 2nd century BCE. More recently, about 700 years ago, Muslim mathematicians created the first tables, allowing them to locate answers to this type of puzzle quickly. Tables similar to them appeared in school math books until recently. What happened recently? We got the calculator. Okay, here are some clues to help you figure out how the puzzle works. Use the clues to determine the missing pieces of the puzzle below. Okay, I want you to stare at this and figure out how the puzzle works. I am not going to steal your dopamine here. Figure it out. It's fun. That's because no one's already.
Oh, my God.
Don't steal their dopamine. No.
I'm kidding. Oh, I'm standing now. I understand it now. You understand it one day. Okay. Okay, wait. No.
When you figure it out, start to answer the question A through F. You can phone a table mate if you figured it out, or if you did not figure it out, someone at your table did.
Total was, look at 2 to 16. 2, right?
So how do you play?
No, it's true.
That's got it.
Since that was two.
That's okay. We'll just set it. Just say it. Okay, then start to answer the questions, A through F.
Okay, wait. Four, 16.
Yeah, but 3 to the 2 is a.
2 to the 5 is 25.
Yeah, I don't get that.
It's 5 to the 2. So it would have to be 2 to the something. To the something. Five to. It would be 5. Or C is 10. 100 to the negative. 100 to. Can't hit me anywhere. No, it wouldn't be squared.
100 to 1/10.
100 to the. 100 to the 6.
Why don't you guys try stuff on your calculator?
So we weren't allowed.
Oh, now you can, well, it's not gonna do the log for you.
I think it's like. My log is a wee level.
I remember Justin was telling me about this. He said that this is like one of the harder things that we do this year. Logs it is.
Mhm. It's not this, this is easy, it's the properties, when we start to work with the properties, because, yeah. No, it's chapter 7. They behave like exponents, and people don't like exponents, so, so they don't understand the properties.
0.5.
I'll give you a hint, A is 4.
Oh my God, log is probably.
Me too.
That doesn't, that, you don't need that.
It's not gonna get done. I got the C. C is 4. E is.
C is definitely not 4.
C is definitely not 4. C is not.
A is 4.
It starts with you check your homework with a partner, and then you like share it aloud. And then,
Oh, so that's.
then he passes out the books and you do the question. That takes like a half hour. And then you get a questions does or like total. And then you get a Omaha de Chicago. And then. And then you take, yeah, I was just, but we have a test next Tuesday.
Yeah, I'll tell you.
What if you went this hour? Not using it. They show us.
You see that we work with musketeers? 3 muscles.
Oh, yeah.
3 muscles, they look different, they have way more health, they should look slower, but they do more. Fireballs, I'm not 3 muscles. Oh, no. Yeah. Well, I'm not really happy, but I'm go hog. No, you go hog, it's gonna run, yeah. They're gonna go hog, no, they're gonna go fireball, so they're gonna make all the way. If you go, I know. No, you're flying the air to the. So someone puts a cannon down, it was like a silly girl, but, yeah, basically. Every individual hog.
Okay, check them. You need to know that half exponent for square root. Half exponent is a square root. So, 100 to the 1/2 is the square root of 100, which is 10. Okay, now, this is it's very important. I'm going to refer to this as the Guinan circle for the rest of the year because Mr. Guinan taught me how to do this in a very easy way. What I want you to do is take your little 5 here and make an arrow that goes around. Okay, so this is the pattern. I'm going to call it the Guinan circle even next year. But this is the pattern we follow. This is the base. And it's also called the base of the log. So it's the base of the exponent and the base of the log. Same terminology. To the 2, that's the exponent, is the answer, equals 25. So follow the arrow around. 5 to the 2 equals 25. That's what I want you to do with your eyes when you're doing these problems. So you start here with your eyes. This to the this equals that. Okay. All right. Now, how does that have anything to do with what we're learning right now? And that's because if I take this and say, okay, this is 5 to the 2 equals 25. I got that from my circle. Can I take this and apply it to this and rewrite it to that? Okay, so what I'm going to do is take these things and go backwards and write it like this. Okay, so come over here to this space for number 55. Okay, so here's your original exponential that we did over here. And I have a question for you. What is the base of my exponential? This exponential is base 3. Can you guys tell this is base 3? Can you tell this is base 3? Okay, so the inverse is going to be log base 3. So exponential to inverse, when you're writing your steps, is going to be log. So undoing an exponential is going to be doing a log when you're doing your steps. And we're going to practice this a lot, but this was the very first baby bit of it today. Okay. So I think you guys have like 15 minutes to cram study if you want. What's wrong?
I think we're ready, right?
I think I'll interrupt you at 12:30. We do. We have a, oh, yeah, so now you could cram study for 15 minutes.
Study.